Today we will see what happens inside the transformer when it is at load or whenever it is at no load. What happens exactly? Okay. Now at no load is left side and on loaded is right side. Okay. So when on no load, what happens to primary side? Primary side, small magnetizing current flows 2 to 5% of full load current. Only 2% or 5%. Very negligible current will flow through primary side when it is on no load. Current creates magnetic field in core. What will happen in core? Current will create the magnetic field inside the core, silicon steel core, where winding is wound or around it. Then most energy goes into magnetizing the core. Maximum energy, this 2 or 5% energy goes into magnetizing the core. Then small losses in core. What are the losses? Hysteresis and eddy current losses. Eddy current losses we have seen in last lecture, right? Hysteresis is what? It is like inertia. Okay, so in AC, what happens? Current goes from 0 to 90, then it changes the direction, and again it goes to 0 and again 90, and again it changes the direction. So this directional change is opposed by the magnetic field. Okay, so it depends on the material as well. See, if vehicle is moving in one direction and you abruptly ask it to reverse it, what will happen? It will brake, and that brake energy will go through tire to the ground. So that heat, sometimes if you see racing cars, entirely in racing cars you can see smoke. So heat energy is coming out of tires. The same way, magnetic field is going at 90 and again it is changing the direction. That time what happens? That energy is getting converted into heat. So that is called hysteresis losses. When it is changing direction, the hysteresis losses happens. Those are negligible. Just to let you know, it is a inertia to the changes of direction in the magnetic field. Now, secondary side. Okay, first we will see what happens to the primary side whenever it is full loaded. What happens primary side? It is full loaded now. See the current. Okay, load current flows proportional to the secondary load. Here only 2 to 5% for the magnetism in the field or core. Here it is proportional to the load. If load is 50%, load current will flow to 50%, not like 2 to 5%, 100%, 100%. Okay. Now, primary current is equal to secondary current divided by turns ratio. Okay, turns ratio. Let's say primary winding has 100. Let us take an example of step up transformer. Primary is 1, secondary is 2. This is step up. Now in step up transformer, why did we step up the transformer? Because to bring down the current, right? That is why we will be able to flow the power from one location to another location if you bring down the current. Remember, now, secondary current. See, primary current is dependent on secondary current. Let's say secondary current is 10 ampere and divided by 1 divided by 2. So this 2 will come up. Okay, so it will become multiplied by 2. So 10 multiplied by 2 is equal to 20. So primary current is 20 ampere, secondary current is only 10 ampere. Okay, so half of the primary current, because current ratio is up, current ratio is double. Okay, now we'll see what happens to the secondary side when it is on no load. Full voltage available at terminals. Both the terminals are full voltage is available. Say at secondary, no current flows because it is open circuit. No current. There is no closed loop. No load connected. No energy transfer. Obviously, how will energy transfer? Because no load is connected. Then in secondary, what happens when it is fully loaded? Load current flows to the connected equipment. If you connect the equipment to secondary, entire load current depends on its resistance current to the equipment. Secondary voltage drops slightly under load. If load is more, secondary voltage will be down. Pressure, voltage means pressure. Okay. If load is more, like we have seen in current, how current flows, if the resistance is more, if in water flow the stones are more, we will need more voltage, but voltage drop will be there. Okay. So energy transfer from primary to energy through core to secondary. Primary to energy transfer is through core. Through core energy is transferred. This is primary, this is secondary, but core are connected. Okay. Now, what happens to the power consumption whenever there is no load? Only losses consumed, only core losses consumed. Okay, core has some losses which we have seen, small losses, hysteresis plus eddy current losses. Typically 0.5 to 2% of transformer rating. 0.5 to 2%, very less. Example, 1000 kVA transformer consumes only 5 to 20 kilowatt at no load. 5 to 20, negligible, because its rating is 1000 kVA. Now, in power flow, what happens in when it is fully loaded? Real power transfer from input to output. Real power transfer. Then primary power is equal to secondary power plus losses. Okay, secondary power plus losses will be there. Then efficiency typically 97 to 99% at full load. See, current comparison. In no load, primary current is 25, secondary is 0 because it is open. Power consumption 10 kilowatt. Okay, core losses only. At full load, primary current is 91 ampere, secondary current is 2500 ampere, and power transfer is 1000 kilowatt at full rating. Here only 10 kilowatt. Okay, that we have seen. Now, key observations. What are the observations in there? Transformer knows how much power to draw based on load. If load is more, it will draw more current. It will not draw unnecessary current. It entirely depends on the load, how much load you are putting on it, and that much amount of power it will draw. Okay, it knows. No load current is very small but always present. Okay, no load current is very small but always present because it has, that core has some losses. Okay. Now, voltage regulation, slight voltage drop under load. We know that if pressure, we need more pressure, if, and there will be some back pressure as well if load is more. Okay, voltage drop will be there. Now, efficiency improves as load increases. Obviously, if load is more, efficiency will go up because current will go up, the power consumption will go up. If power consumption is more, the percentage is definitely negligible. 1000 kilowatt. If 10 kilowatt, percentage will be more. Okay, if current is there. So more load, more efficiency. The transformer should be highly loaded. Maximum load we should put. This is the outcome of this topic. Then practical implications. Unloaded transformers still consume some power. Multiple transformers in parallel share load automatically. Automatically they will share the load if it is in parallel. Transformer sizing based on maximum expected load. Maximum. In that case, let's say connected load we can say, or maximum load, the size is dependent on that. We will see how the transformer design will be done. We will see later. But still, you remember maximum expected load, the transformer size. Power factor of load affects transformer current. This also we will see in detail, power factor, how it affects the transformer current.